Hey guys, this is the second part of the Advanced Java. Let's see what we got for this lecture. So I'm going to talk about two topics, Java type system and Java enumerated type. What is Java type system? Okay, before that, uh, first we need to know what is a type. So the definition of type is this. We have usually a set of values, or in object-oriented, we are talking about the objects, and also we have a set of operations that we can run on these values. Okay, so let me take a very familiar example first. So, for example, integer is a primitive type in Java. Okay, it is a type because it has some values that we know they are 32-bit integers, and we have some operations on them, which are arithmetic operations that we can apply on these values. Okay, so we have the same thing for the object as well. All right. Uh, so we have some, a set of values and a set of operations. Let me take an example on the objects. For example, employee class is a Java type. Why? Because we have some values. All of the objects that we can instantiate from this class are the values, all right? But the point is, not only those objects are the values of this type, but also all of the subclasses of employee can be considered as the values of this type. Yeah. So these subclasses, under this topic that we are talking about, type system, it also is known as subtype. So, superclass and subclass. Now we have type and subtype. Okay, so these are the values, and uh, the operations would be the visible methods of the employees. Okay, so now let me ask this question. Why did I say subclasses? So why did we consider the objects of employee and its subclasses for the values? So this is an important question. And the answer would be because we want to satisfy the polymorphic relationship. So if you instantiate, for example, employee, uh, let's say emp equal to new employee, yeah. So this emp also can be assigned a manager, for example, new manager, which is a subclass of the employee. Yeah. So, so because of this polymorphic relationship we have, then we would say all of the objects of the employees or the objects of its subclasses are considered as the values for this type. All right. Okay, so now the question is, what is type violation? When we say a type is violated, it means that we are assigning or passing a wrong type to a variable. What does it mean? Look at this. And we know that this is a violation in Java. So integer x, so you assigned a string to it. So this is a type violation. Okay. So now the very next question would be who's in charge to detect this violation? That's a very important question in programming languages in general. Okay, so the detailed answer to this question should be started in the programming languages paradigm course. But here, briefly, we answer this. So, who is in charge to detect and prevent type violations? All right. So, in Java, which is a strongly typed language, the compiler won't let you go further. The compiler will complain when you say int x equal to a string. The compiler won't let you go further, and that's the beauty of the uh, a language like Java, which is a typed language. It's based on the types. Type are very important in Java. Okay, so but you know what? In other languages like C, Python, JavaScript, they are not typed languages. At least they are not strongly typed languages. And that they just rely on the programmer, the skill of the programmer, that don't make a mistake, which is a wrong assumption. We cannot rely on the skill of the developer. As I said many times so far, we always need to assume that the user of your code is a rookie. Okay, so we need to be very careful, and we expect that the language helps us. And Java is that kind of languages. Of course, we have other languages. For example, C++ is the same, but it's not as a strongly typed language as Java is. Okay, now let me ask this question, that uh, compile time or runtime detection, which one is better? Of course, compile time is better. If we can detect a program, an issue in compile time, it's the best. It's the lowest cost is this. All right. Because when you write your code and you submit your code, and if anything happens, it would be a costly operation to modify that. But compile time is the best. Okay. So fortunately, in a language like Java, most rules of type and subtype can be validated in compile time. Why I'm saying most? Isn't this all of them? No, it's not the case. We have some cases. Probably the simplest one is this. Look at this example. For example, object. Let's call it opt, for example, equal to new employee. Can we do that? Yeah, of course we can do that, because we said object is the parent of all of the classes, right? So object is here, and all of the other classes like employee uh, uh, inherits from the object class, right? So there is an is-a relationship between them, and we can use the polymorphic relationship like this. Okay, so now what? Now if you assign object to something else, for example, I don't know, for example, a new rectangle, it doesn't complain. So this is a simple example to show you that it's not the case that all of the rules of type and subtype in Java can be caught during the compile time. Okay, so with this background in your head, now we are asking this question that how many types Java support? Java supports 5 different types. First, the primitive types that we are familiar with them, integer, short, long, and the rest of that. It supports the classes, cat, dog, employee, and whatever. Yeah. And interface, yeah, interface is a type. Arrays are a different type. And this is a surprising type, is null. Yeah, we have a null type, and it is, with capital N. Okay, so probably you're asking why, where was this? Yeah, yeah, there is. Because the point is when we have a value in Java, every value needs a type, okay? And null is a value, right? So it needs a type, okay? So all of the values in Java, either they are primitive or they are reference to an object, they are referring to an object, or they are referring to an array, or it is a null. So all of the values in Java are not out of this set of values that I just mentioned. So what is this? What happened to that interface type? We had 5, right? But I mentioned here 4. Yeah, actually, the 5th one is the interface type, which we can categorize here, right? But even though it is not object, but it is a reference. So in fact, interface type, we can use it for the declaration for other classes. Yeah. So, but we cannot instantiate an interface, as you know. Okay. So interface type can be used all of those 3 locations that we are familiar with. So we can use the interface type for the variables, local or instance. We can use it as a method argument, and we can use it as a return type. Okay, so yeah, I think we have a good introduction about the types. Now, let me give you some notes about the null type. As we said, every value needs a type and null is a value. That's why they had to define this null type. But since they define this null type, it is not the case that you can say, for example, null, like any other classes, let's say, for example, x equal to new null or something like that. Yeah, we don't have such thing in Java. Okay, so yeah, we don't have this. Okay, now let me ask this question. So we learned that null is a type because we needed to put this null value somewhere. Okay, so how about the void? We have a void that we can use as a return value. Yeah, is this a type? Is a value, or it is something else? Yeah, the point is that void is none of them. Actually, it's not a value, it's not a type, it's just a keyword. It means that no return value. Okay, so there are some criticism about these exceptions that I just mentioned. For example, if we have a type, how come we cannot instantiate it? Or if we have a return, we put this void as a return, why it is not a type? So all of these exceptions are not good. So there are some criticism on Java that why this kind of exceptions happen. What is type-subtype relationship? We would need a precise definition about the type and subtype. Okay, so this is a very important relationship. We need to be very clear about that. So why is this the case? Let me take an example. Let me ask a question. Let's say that manager is a subtype of the employee class. Subtype, when we say, it means subclass, yeah, of employee. All right. So the question is this array is a subtype of this array as well? Because manager is the subtype of the employee. Is this the case that the array of the manager is also a subclass of the employee array? So these kind of questions are, a valid questions, and how can we answer them? We need a, precise definition when we can say there is a type subtype relationship between the entities that we are familiar with, right? Okay, so, and this is a very more general question about the S and T. So when can we say that S is a subtype of T in general? Okay, so to answer this question, this general question, we need to define precisely the type-subtype relationship rules. Okay, so here is the rules in Java. Uh, First of all, if S and T are the same type, then we can say S and T are, have type-subtype relationship. Okay, so probably this is coming from the set theory. So for example, A is a set and it is a subset of itself. Yeah, and here we would say S and T, if they are both the same, we can say that there is a type-subtype relationship between them. The second rule is if S and T are concrete classes and S is a subclass of T. So we have T here and we have S here, which is a subclass of T, then definitely this is very obvious that S is a subtype of T. How about rule number 3? If S and T are interfaces, both of them are interfaces, and S extends T. You know that interfaces can extend each other, right? So if, again, T is an interface and S is another interface, and they, extend each other, there is an is-a relationship again between them, and we can say the S is a subtype of T. How about rule number 4? Rule number 4, T is an interface, but S is a concrete class that implements T. Okay, so T is an interface, and we have S, which is a class, but S is implementing T. Again, there is a is-a relationship, which is type and subtype relationship between them. All right. Next rule is S is non-primitive, which can be anything, yeah, and T is the object class. Oh, that famous object class, which is the parent of all other objects. Yeah, so if here we have the object and an S can be anything, the only restriction is that it is non-primitive. Okay, so definitely there is an is a relationship again, which is type and subtype. Rule number 6 is regarding the arrays. So if we have an array, let's say S is an array like this, and we have a T array like this, we can say this array is a subtype of this array if S is the subtype of T. Okay, so we have some examples that I will talk later. Okay, and also just know that there is a new term here. So S array, the S type, whatever it is called the component type of this array. Okay, all right, and the rule number 7 is null type. If S is a null type, when we say S is a null type, because null has just only one value, so it means that S is equal to null. So null actually is the subtype of everything, all of the non-primitive types. So, so that's why we can pass the null for every variable. Of course, I am talking about non-primitive values. So we can pass or assign null for every non-primitive type because of the polymorphic relationship. So that's why we are saying that null is the subtype of all of them. Okay, so probably this is coming from the set theory that you know that the phi is the a subset of all sets. Yeah, probably this is coming or inspired from that theory. All right, so let me take an example from the array that we just promised that we will take an example. So here is the example. We have manager array and we have employee array. And we would say this array is a subtype of this array because their component type has a type and subtype relationship. Because manager is a subtype of employee, because of that rule number 6 in the previous slide, this array would be a subtype of this array. So if I want to take an example here, so this would be a valid relationship. So employee, we instantiated with 10 employee array like this, but we can, assign to the same variable the new manager array as well. Wrappers for the primitive types. So what is the wrapper for a primitive type? So we know that Java supports these 8 primitive types: integer, short, long, byte, float, double, char, and boolean. And here is the list of the bits that they will occupy. And Java created the wrappers for all of these types. So these are the wrappers. So because these are the primitive types, sometimes we would need some classes the same type or the same nature, right? So these are called the wrapper classes for primitive types. And just look at all of these, you know, except the integer, which, it is, integer, the full integer, but here we have int and character char. The rest of them, just if you capitalize the first character, we will have the wrapper. So again, we don't like these exceptions. Why these two are exceptions? All right. Okay. Now let me ask a question. Why Java created primitive types? It is an object-oriented programming language. Everything should be object, right? Why the primitive types were introduced in Java? This is another criticism about the Java. Okay, so the answer for this is for efficiency. So you know that primitive type, it just occupy a few uh, uh, bits. For example, in int, we said that it is 32 bit, right? But the integer class or the wrapper class for int, since it is a class, it's an object, it it takes at least 4 times of this 32. So in other words, Java created primitive types, but that because we know that there are a lot of operations with the primitive types in the programs, right? And just imagine that if we needed to use classes instead of the primitive types, then the amount of the memory that we needed and the efficiency would, decay for the wrapper classes. You see, so because of this, for efficiency purposes, Java created the primitive type. And it is valid to ask the question, so why the wrappers were introduced then? Yeah, in some cases, we need an object. For example, here, when you are creating an array list, yeah, you cannot put here int. It expects an object here. So the wrappers were introduced because of this situation like this. Okay. Another thing that you need to know is, which is just a recapturing from the previous courses you passed, is the concept of auto-boxing. What does it mean? When we have an integer like this, we can assign it directly to a class, a wrapper class like this. Yeah, before uh, before the Java 5, we couldn't do this, right? And we had to create, I mean, instantiate the wrapper class like this to be able to assign a number to a wrapper class, right? Here we can do that easily. Java support that, and it is called auto-boxing. How can we inquire a type of a variable? So it is called type inquiry. Let me explain some situations that we need this. Okay, look at this. We have instantiated an employee class here, right? And we have a variable here. And in other part of the code, let's say that we want to know whether or not this employee variable is a type of employee or not. Or we want to, inquire, or we can check that whether this employee, what is the type of this employee? Is it employee, this kind of object or not? Okay, so um, in general, we can ask this question. We have a variable and we want to know that whether or not it is referring to a given type or not. So here, for this purpose, we can use an operator that we call it instance of operator. And here is the syntax. So this is, the code that I showed you in the previous slide. Now we want to check whether this variable is this type or not. So we can use this operator. Is employee instance of the this class or not? So just look at this. We mentioned the class here. All right. Okay. So this comparison or this this if statement returns true if employee variable is really instance of employee class or its subclasses. So if really employee variable is of type of manager, this if statement return true as well. Yeah, that's the problem. So this is not a precise response that we expect. Okay, so yeah, the question here is raised, how can we precisely respond to this question? How can we ask this question precisely that, hey, employee is the type of this employee, not the manager, for example. Can we do that? Yes, we can do that. Okay. So before that, let me give you just one usage of these kind of if statements. Yeah, you might say, okay, why should we ask this question at all? Why should we be interested to know that what is the type of a variable? Yeah, there are some situations. Let me at least mention one of them. Yeah. So, for example, if you want to cast an object like something like this, so let's assume that we use this object argument and we are passing some stuff here, and then we need to cast it before using this. So this object will be casted as employee and we assign it to a real employee variable like this. So before this casting is one of the usages of using this instance of. So we want to check that, yeah, is it really the type of employee? So if you don't do that, if you don't check that and just make a casting like this, and if it's not really an employee type, then an exception will be thrown. That's the embarrassing thing if you don't take care of that. Okay. Now, based on this knowledge in your mind, let me ask again, how can we precisely check the type? Okay. So to answer this question, we would need some background knowledge. I'm gonna introduce a new class that is called class. So I'm gonna introduce class. What is this class? Okay. So when you run a, a, a Java application, let me tell you briefly what happens. When you run a Java application, a JVM process will be run on your operating system. So in other words, JVM or Java Virtual Machine is a process inside your operating system. So let's say this is an operating system program. So in operating system, you have some objects, yeah, different services, objects, and one of them is a JVM, this guy. So one of them is this guy. Okay, so now that we know JVM is just the process, so inside the JVM, what do we have? So let's say this is JVM process. There are a bunch of objects of your application. I am talking about your application. Yeah. So this is employee, this is a manager, and this is whatever. Yeah. There are a bunch of manager objects that are communicating with each other. So your application, in fact, which is, an object-oriented application, is just a bunch of objects that are communicating to each other. Now the question is, how JVM keep tracks of this? So JVM has a technique to keep track of all of these objects that are created and are communicating with each other, right? We are not gonna go inside in detail that how JVM works, but you need to have a big picture of what is going on. So when you create an object, let's say an EMP, for example, right? There would be um, a class object. So this is a class. I wish they name it something else, but its name is class. So the class is a class really, and its object is like any other objects in Java, right? This class will be created for, let's say, employee object, and um, it refers to this guy, right? And its job is to keep track of the whatever this object has, and JVM internally use this object to handle objects like the employee. So for every class like employee, right? Only one class object will be created. So maybe you create another, let me show you this way. So this is employee, let's call it employee 1. It was created from this employee class. Let's call it employee 2. Employee 2 is another object created from this employee class, right? But for all of them, only one class object will be created internally. And this class object will handle and keep track of whatever these objects are doing, right? The mechanism and the detail is beyond of this course right now, but just keep in your mind that a class object will be created. So this class guy, all right? So how can we have a reference from here, for example, to this class? Yeah, but it is hidden. It is hidden to us as the developer, but we can have access to this information. I will show you how we can access to the information that exists in this object, the class object here. All right. So the only thing that remains here, I explained. So this class also is called type descriptor. Type. Okay, so all of the explanation that I just gave you here, I mentioned here for your reference. Let's continue. Okay, so as we said, all of the needed data are inside that class object. Yeah, and since this is a new term here, since we are keeping track of the data, so let's say this is an employee and this guy is that class object. Yeah, so since this guy is keeping track of all the information about another data, so employee is an object, right? But it has some data. So in other words, this object has some data about data. So it's a data about data, and that's why we call it metadata. And we have the same concept in the database as well. So in database we have some tables, right? But also, this is just, let's call it user tables, right? But also behind the scene, we have some other tables that keep track of these user tables, and that's we call these tables as the metadata. Okay, all right. And the point that you need to know is this class that we are talking about is totally different that object class that we already know about that, which is the parent of all of the classes. So these two are totally different thing. So that object is visible and we can work with that. This class is hidden. Yeah, we can get some information about that, but in different way. Okay. So now the question is, how can we access to that class object? We have actually three ways to do that. Okay. So the first way method will be using the get class method. So this get class method is familiar. It looks like it's familiar. It is coming from the object class. You, you know that this object, which is the parent of all of the classes, has some methods, right? We mentioned that before. So for example, equals, for example, clone. Yeah, you remember that? And one of them was get class that we didn't talk, and now we want to talk about that. Okay, so the get class can be used to get that class object. How? Here is an example. Yeah, so this is an employee we instantiated here, and now we can use this variable and call this method. So this method is coming from the object class, and this is the type of the that class, which is called class, and this C. Now you can get a lot of information from this C. Okay. Okay. The method number two is using the class literal. Let me take an example to explain that. So again, we instantiated the employee class. Now we can use this keyword, this syntax, to get the class object. Look at this. So the employee is our class here, and this dot class is something that is familiar. Uh, so this definitely this is we are not calling a method here because it doesn't have this parenthesis. So this should be a variable, right? And it should be an static variable, right? Because we are calling it in static fashion. Yeah. All right. So we can conclude from here that if we can do this, it means that inside the employee class, so let's call it employee, when you instantiate it, Java put an static uh, variable here, instance variable. It should be a static. That's why we can call it like this. Okay, so in the documents they call it class literal, but this is my imagination that it should be something like this. So the class here, this it is a static class, and its type is uh, type of the class. So it is hidden to the developer, but since we can use this syntax, it means that it should be here, something like that, right? So this is the second method that we can get that class object, right? And all of these are for reference. Two things I need to tell you about this technique, the technique number 2. First of all, we can use this technique to get the information of this class for other classes, interfaces, and also the primitive type. What? Yeah, we can, primitive types, we can use the same technique and get the class object. So let's say class C equal to, for example, int dot class. It will give you exactly this class, and you can use this and to get some information. We will take some, at least one example what information I am talking about. And also the second point about this technique, this method number 2, is it's more popular than the other ones, right? And the third way, the third technique or third method is to use this method from the class, which is an static method. Yeah. So here is an example. So look at this. We are using the class, and we are using the static fashion to call this method. And inside this method, you would need to pass the name of the class as a string, but it should be fully qualified. It means that you need to mention the package as well. When you pass this string here, Java will give you again the class object. Okay. So let's now get back to our problem. We were looking for to checking the object's type precisely, and we said that instance of is a good operator, but it does not give us the precise answer. So now, after this introduction that we said about the class, now we can use that knowledge, and here is how we can precisely check whether the type is employee or not. So this is instantiation of the employee. So we can call this employee, and we can call this method, and this method, that it gives you the class, the type of the class, and you can compare it with the second method that we learned, and to make sure that this employee is exactly the type of the employee or not. So in that case, if this employee variable is not exactly this if statement does not go through. What is Java enumerated type? So let's assume that we have a class called shirt, and this shirt has a name and a size and a regular public constructor like this, name and size. Okay, and how can we call this shirt? Is easy, just we instantiate this constructor with the shirt name and the shirt size. Do you see any problem here? Yeah, you just pause the video and think about it. What's the problem? Do you see any problem? Yeah, we see this magic number. What is this? We shouldn't have such an undefined numbers in our code, right? Okay, so how can we cure this issue? Yeah, so the first remedy that cross our mind is to define some public constant. When we say public, static, final, these three guys make a global constant. All right. So the public make sure that we have access in whole the application. Uh, it is accessible. I mean, the static make it um, be accessible in the whole application, and final makes it to not being able to change the value again. All right. So this is the combination that we create a constant in our application. Okay. So can this cure our the problem that I just mentioned in the previous slide? Yeah. So yeah, let's see. Let's see. Now, how can we instantiate this shirt class? Very easy. Instead of using that magic number, we now we have a defined constant, right? Okay, so let's see, do we have any problem with this in the next slide? So definitely this is a one step better, but unfortunately it's not satisfactory because look at this. Let's say I define an integer like this, and it I instantiate because this guy is an integer, right? So you can assign this to this shirt size, and then by mistake you can increase that and or change it or add it with something else. Now we don't have that shirt size that we intended, the three sizes that we intended. Now we can use this shirt size as a 4 and 5 and whatever, right? So, and unfortunately the compiler cannot catch this kind of mistakes, right? So always think that this is not the case, that we have a very simple class like this. Always think that it's hundreds of classes, and these constants are in one of the classes, and in, let's say, 50 class later you want to use it, and a rookie programmer make this mistake. Yeah, now start debugging and finding the uh, problem. It's a chaos, right? So let's see, how can we cure this issue now, right? So let's see what is the Java solution for this. So Java solution is enumerated type. Let me explain it here in this our previous example. So this is our previous example, public class shirt, and I still have the name, but instead of defining an integer here, I create a new type, and we called it enumerated type, or in short we said enum type, like this. Look at this. So public enum, and we give a name here, whatever it is. But the tradition is like the class name. You start it with capital letter, and then a small, medium, large, and whatever you want you can add here, and that's it. So this is we created a new type here, right? And what would happen to the constructor? The constructor, and this is the instance field, whose type is the size, now this size, and the constructor again is using the type size. All right. So instead of the integer, we created a new type for this, these values, small, medium, large. Okay. So, so the good news here is that mistake that I just explained in the previous slide could not happen. I mean, you cannot say, for example, size plus plus, or you cannot, assign this size to an integer. You cannot do that. And the good news is that the compiler will prevent you. Okay, so this is a very huge, actually, improvement to the code. And let's see how the client looks like. Exactly the same thing, but like this, size dot large. So it looks like that, this public enum size, we can use it like a static class. You see, we mentioned the class name and then the value that we just mentioned here, right? Okay, so let's see. Let me show you side by side the old code and the new code by using the enum, and let's see how they differ. So this is the old one. The same one is here. So here we just created this part, and here you remember that I tried to simulate the medium one, small one, medium two, large three. And this is the our instance field that was integer. Now it is type of size. And the constructor, you see, integer changed to this one. Okay. Now let me tell you what would happen behind the scene. When you create something like this, what does it mean? We have not seen it before, right? Probably most of you have not seen it before. Let's see, when you create such thing here, how Java behave that, right? Let's see. The fact is that when we create a enum inside a class like this, behind the scene, Java create a class for that. So it means that Java replace this portion of the code with a class like this. So you see, public class, the size, public enum size, and for the small, medium, large, we will have three instantiation. And so in fact two pieces of the code, this guy and this guy, are equivalent, right? And note that this is the constructor of the class, and automatically Java behind the scene created as a private, because Java can, doesn't want you, you be able to, instantiate it, right? It instantiate by itself. And then with this public static final, it gives you access to all of these values that we tried to simulate in the previous slides. Okay? All right. So let me now give you some notes about the enumerated type. The first thing that you need to know is about the null value. So by default, a null value will be added to all of the values that you create, right? So this guy. And as we said, enum type is a class, right? So if you had a question that when we say it is enum type, it's a type. If you had this question, okay, so why we didn't mention that before? Before we said Java data types have 5 data types: primitives, class type, interface, array, and null. We didn't mention about the enum, right? And now we learned that enum actually behind the scene is a class. That's why we didn't mention that. Okay, so since enum is a class, we can define it in its own file. We can, make it independent of any other um, classes. In the previous example, I created it as an inner class, but it can have its own file, right? And the other thing, again, it is class, so it can has other constructors. It can have methods. It can have attributes, right? Let me take an example to show you how it is possible, right? It's just a simple example. Look at this example, right? First of all, I created this independently. I mean, it has its own, file. And the second point that you see here, we assign different values instead of giving them natural number, let's say 1, 2, 3. I decided to make the small a value of half, zero 0.5, 1, and 2.5. You see? So in this way, we have the flexibility to change the integer numbers that are assigned to these values by ourselves, right? So by default, Java assign the natural numbers, but we can change this behavior. Another things that you can see here is I added this guy, which is an instant field, right? Yeah, we can do that. And I added a method here, right? Get value. But note that the constructor is still private. It cannot be instantiated outside, right? As long as it is enum, this is the limitation and difference between a regular class and enum. And another point here is that you should put these guys at the beginning, otherwise you get an error. That's weird, I know, but it is what it is. And as I said, the constructor is private. I explained that. Okay, now let me show you how can we use this. So this example, how can, what is the client for this? Very simple, right? We just instantiate this regularly, and this size point large, we have seen this before. So there is no changes here, right? But if you print this size large like this, so if you print the size large, it will give you just large. But if you get the value of that, it brings the value that we assign to it. So the output of this code would be large. This is actually the default behavior of the enum, and this is actually is just a regular class. We are requesting the value of this guy. Okay, so that's it. Just let me give you some other notes about the enum. So enum class automatically extend the enum class, this guy. So every enum you create, automatically it extend this class, right? And since it's an extend, so it's a super, this is a super class, so automatically enum classes inherits some stuff. So some stuff, some methods and some other things. And one of them is yeah, just toString. So let me take an example. Yeah, you see. So size is small dot toString. And also, you know that we can eliminate these toString. We have seen this before because so since this is println and Java expect to pass a string here, if you just eliminate this, by default, Java invoke the toString, right? Yeah, that's it. So this is the enumerated type. I am gonna stop here. See you guys in the next lecture.